Good morning, good afternoon, or good evening to everybody that's joined so far, depending on where you are in the world, and welcome to the PackHub's latest webinar, Sustainable Packaging Innovations. I've started every meeting this week with a remark about how warm it is. I hope where you are, you're not struggling too much in this incredible heat. My name is Paul Jenkins, founder and CEO of ThePackHub. I'm delighted to be joined today by Matthias Krätschell, Business Creation Manager for paper and board barriers for Kemira. Today's agenda, welcome and introduction, and then we're going to, as we always do, split the packaging innovations across two sections. So the first section will be refill and reuse, bio-based materials and reduction strategies. We then got a presentation from Matthias regarding from regulation to repulping, meeting recyclability demands with dispersion barrier coatings. So I'm looking forward to hearing all about that. And there's an opportunity with our Q&A to ask any questions. So please make sure you note any questions in the Q&A box on the Zoom panel. After Matthias will then summarize the remaining sustainable packaging innovations from our innovation zone and pattern zone platforms, with a look at the latest recycling and recycled content initiatives, followed by paperization. And as I said, we've got a Q&A about 10 to the hour, so please get your questions in when you can. A little bit about the PackHub. Most of you know us and have known us for a while, but for the unacquainted, we're a packaging innovation consultancy. We've a number of products. The innovation zone, where the inspiration for most of the innovations you will be seeing over the next 55 minutes or so come from this platform, nearly 12,000 case studies from around the world. We also draw from our patent zone platform, and just recently marked 2,000 packaging patents from around the world on that platform. I'm delighted to announce the introduction launch of Innovation Plus, which will be our best packaging intelligence platform yet. I'll give you the opportunity to scan there. If you wanted to a free trial and more information, please scan that QR code and we will get more information to you ASAP. That launches next month. And a summary of all our services. So we mentioned Innovation Zone, the Pattern Zone, Innovation Plus. We have packaging training through the Packaging Academy, innovation services run by our innovation director, Katie Rosler, events and webinars, supplier partnership program, packaging startup awards, and our brand owner and retailer summit, which this year is on Tuesday, the 29th of September in London. Last but not least is to mention our Pack Ready innovation and design support initiative. Pack Ready brings together two sides of the same challenge. Our partnership with Valpak brings the PackHub's global packaging innovation database with Valpak's expertise in compliance, recyclability, and carbon assessment. So the result is a more informed way to move from initial ideas to packaging solutions that are validated, practical, and ready for market. So that's enough about the PackHub. Right, so the first thing we always do is sort of break down the sustainable packaging trends into 5 sectors. So I've already mentioned these a little bit. So in the first half, the first part of this, we'll be looking at refill and reuse, bio-based materials, reduction strategies, and then in the second part, we'll be looking at recycling and recycled content and paperization. So without further ado, let's look at some refill and reuse systems. So refill and reuse continues to be a quite important long-term packaging innovation area. We're tracking a number of initiatives on both the innovation zone and patent zone. And this is really driven by the need principally to reduce single-use packaging, cut carbon impact, and support a circular economy. The trend is moving beyond early pilots and trials into some more structured commercial models, including refill at home, returnable packaging systems, in-store refill stations, reusable takeaway packaging, and deposit-based schemes. It's still a tricky and challenging area. I was in Madrid at a FEFCO conference 2 or 3 weeks ago, and I went to take a look at what was going on in the store. one of the local stores, and to be honest, there was absolutely no refill and reuse. So what with the innovations we're tracking, it belies sometimes the actual in-market examples. But I have got some examples to show you today. So the first is from Dunny Group through its Revelo brand based in Munich, and they've introduced a large-scale reusable packaging system at Munich's largest open-air market, covering approximately 222,000 square meters and hosting around 130 vendors. The market attracts 5 million visitors annually, providing a high volume setting for testing and operating circular packaging infrastructure. The initiative, known as Remuck, allows visitors to purchase food and beverages in reusable cups and bowls that can be returned at multiple locations throughout the market. They're enabling returns 24 hours a day and automatic refunding and customer deposits. The infrastructure has been designed to process more than 2 million packaging returns each year. So we watch that new initiative with interest. Next up is from the UK. Reboxed is a packaging reuse business based in Knaresborough in North Yorkshire, and they've launched a service focused on extending the lifespan of cardboard packaging through collection, grading, and redistribution. The company's model centers on recovering used cardboard boxes that remain suitable for further use, rather than allowing them to enter waste streams after a single application. I don't know about you, but when I get a delivery at home, more often than not, I don't reuse the corrugated box. It goes straight into recycling. Kind of feel good about it because I'm recycling, but actually, if you could get some reuse out of that first, that is obviously higher up the environmental hierarchy, so to speak. The company's model centers on recovering used cardboard boxes, and they collect them from businesses and sort them according to size, structural condition, and overall quality before preparing them for resale. I guess the challenge here is the business model, how you can make this cost effective and efficient. The last reuse one from the innovation zone, at least, is kind of touching on the reduction area, really, which is this company called NoWrap, and they're based in Victoria in Australia, and they've introduced a reusable pallet loading securing system designed to replace conventional single-use plastic pallet wrap used throughout logistics. The system consists of reusable backbone corners, loop and lock straps, and steel anchor brackets that work together to secure palletized goods without the need for a stretch film. I guess the challenge here is how quickly that can be enabled compared to existing stretch film, which actually is quite a slow process if you think about the machinery and how many times the plastic has to go round the pallet. So that's an interesting initiative. We're going to move towards our patent zone platform here, and we're going to go to the United States, a company called ZGTL, or probably ZGTL if it's from the States. And they've developed a deodorant dispensing pack, uses a reusable dispenser combined with a removable refill cartridge. We've seen quite a lot of reusable deodorant packs and personal care packs in the market, and this is another one at this sort of the IP development stage. The main feature of this design is that the mechanical parts used to push the deodorant stick are kept in a durable outer dispenser, whilst the deodorant product itself is contained in a replaceable cartridge. This is very much a whistle-stop tour. I want to cover a lot of innovations in a short period. So we're now going to be moving to bio-based materials. They continue to grow as brands look for alternatives to fossil-based plastics and seek to reduce the carbon impact of packaging. The trend includes materials made from renewable sources such as plants, agricultural residues, seaweed, algae, fungi, starches, cellulose, etc. The innovation is expanding across flexible films, coatings, trays, bottles, foams, labels, and protective packaging. Still a bit of a challenge here in terms of the compostable infrastructure, for example. Most markets aren't geared up to accept compostable packaging, so that's a challenge. An issue around consumer communication as well, telling people that it's bio-based and needs to be dealt with separately. So there are a number of challenges in the market, but we are continuing to see many developments taking place. So the first one is from Parkside, familiar to most of us on this call. They've developed a bio-based home compostable lidding film designed for packaging avocados in fiber-based trays. The film has been engineered to provide a combination product protection, visibility, and end-of-life compostability, addressing the requirements of fresh produce packaging. Another lidding film, or this is a sealing film from a company called Norware, based in Switzerland, and they've developed a seaweed-based top seal film for fresh fruit and vegetable packaging, intended as an alternative to conventional plastic lidding films. The NoraFresh film has been designed to align with PPWR requirements that will restrict certain single-use plastic packaging formats for fresh produce from 2030. The material is intended to function as a top seal film for paperboard and cardboard produce trays, whilst avoiding the use of conventional multi-layer plastic laminates. Next up, we do track quite a few sort of mycelium mushroom-based packaging initiatives. The standout thing here is how they look. They look very environmentally friendly, if that's the right expression. So for consumers seeking out sustainable solutions, these shout off the shelf. This is Eco Roots, based in Ireland, and they've developed biodegradable packaging materials using mycelium as an alternative to conventional petroleum-based protective packaging. The company's process combines fungal cultures with agricultural byproducts, including spent grain from breweries and distilleries. And last in this section is from our innovation zone, and it's from Nestle from Switzerland, and they've developed a compostable lid structure for beverage capsules that is designed, when I say they developed, they have IP'd, they haven't necessarily developed yet, a compostable lid structure for beverage capsules that is designed to provide sealing and barrier performance whilst supporting compostable material systems. The key feature of the invention is a multi-layer lid material with controlled adhesive placement rather than full surface adhesive coating. So we'll watch the innovation zone to see if that one day comes to market. Last but not least in this section, before we hear from Matthias, we've got reduction strategies. So this is lightweighting and reduction, which remain core packaging innovation priorities. And they've always been priorities. Reducing weight and cost has always been a priority for brand owners, retailers, and packaging suppliers. This is about reducing carbon impact, lowering transport emissions, improving resource efficiency, and cutting material use. So the first one is Lavazza, headquartered in Turin in Italy, and they've developed Tabli, which is a single-serve coffee system without any packaging. So this is just this sector has always been challenging in terms of the potential waste that it delivers. Although I did read something recently that coffee pods are the second most environmentally friendly coffee way to deliver coffee, but it still does generate a lot of potential waste that isn't necessarily recycled. So in this example, Lavazza have come up with something where they've compressed coffee tabs that are inserted directly into the device, eliminating the need for conventional plastic, aluminium pod, or any other plastic format, any other packaging format. Next up is a company called Sundance from the US, and in collaboration with Sun Center USA, they're expanding the availability of their patented pouch formats. The pouch reportedly uses between 30 to 40% less material compared to conventional stand-up pouches, whilst also reducing internal headspace to allow for increased product volume with the same external dimensions. Next one is VetraPack. Lightweighting in glass has been going on since glass was invented, really. I mean, the interesting thing here is that packaging weight is often a proxy for quality. So it's a real challenge sometimes for brand owners to still communicate those quality values and that premium price point whilst the product becomes lighter and lighter. But here we have a situation from VetraPack, and they've developed a lightweight 0.75 litre, 750 milliliter wine bottle that weighs 350 grams, positioning it as one of the lightest bottles of its type currently available. In Europe, they do substantiate it with some sustainability claims. The reduced weight design generates 33 grams less CO2 per bottle, representing a 13% reduction over a transport distance of about 100 kilometers. And last up, before we hear from Matthias, is from our patent zone, and this is Intercontinental Great Brands, and they've developed an edible tray where the key feature is a highly open structure that reduces material use whilst still supporting the product. I think the standout point here to mention, which I didn't really clock, is that it claims to be an edible tray. The tray is formed with a bottom wall and one or more side walls, but large portions of these walls are replaced with open spaces to deliver. In fact, half of the total surface area of the tray consists of these openings, creating a lightweight and skeletal design. So what it's saying is you don't need to have necessarily a solid pack. You can have these sort of apertures that reduce the amount of the packaging that is used. Okay, everybody. Right, so we've got 2 more sections to cover, recycling and recycled content. And this will be familiar to everyone on the call as a major and significant packaging activity area. Recycled and recycled content remains central to packaging sustainability strategies. It goes without saying the trend is active across all packaging materials. Innovation, if you like, is focused on making packaging easier to collect, sort, recycle as valuable material. Developments include, and we'll be covering some of these, mono-material packs, improved recyclability design, washable labels, detectable pigments, chemical recycling, food-grade recycled plastics, recycled paperboard, closed-loop systems, all sorts of activities. Clearly, regulation is pushing everyone down this way, and with PPWR and EPR, everyone, and the Packaging Pact, everyone's got very, very bold and ambitious recycling content objectives. So first up is from PureCycle. I actually saw these present a really excellent presentation last week at the Sustainable Recycling, the Packaging Recycling Summit in Chicago. PureCycle Technologies are based in Orlando, and they've collaborated with Innovia Films, based in the UK, to successfully produce and evaluate a white BOPP film containing more than 40% post-consumer recycled PCR polypropylene content. The film was manufactured using PureCycle's Pure 5 choice recycled resin and is intended for flexible packaging and roll-fed label applications. I know they're doing a lot of work in this area, and it's quite exciting what they're able to do in terms of PCR content. Next up is EcoPlaza, based out of Amersfoort. I don't know if anyone remembers this retailer comes to mind. So I think in 2018 they were the first to do a plastic-free aisle where all the products up for sale were plastic-free, including compostable and biodegradable packaging. That was a test, and obviously that hasn't been rolled out, but that's a name that comes to mind whenever that's what comes to mind whenever I see EcoPlaza. They've collaborated with textile manufacturer NX Tile, based also in the Netherlands, to develop a reusable shopping bag produced from 100% recycled cotton fibers, including recycled organic cotton waste sourced from textile manufacturing processes. The initiative forms part of a broader program exploring circular approaches to retail packaging and the recovery of textile waste streams. And there's a bigger debate around the carbon footprint, if you like, of plastic bags compared to other materials. What I'm just reflecting is the fact that they're helping reducing the environmental impact by having recycled cotton fibers in the first place. Next up is again from Nestle in the Philippines, and they partnered with Restore Solutions and Robinson's Supermarket to introduce a collection system for post-consumer sachet packaging through reverse vending machines installed in 4 supermarket locations. The initiative focuses on improving the recovery of flexible plastic sachets, which is, let's be honest, a bit of an environmental nightmare. They're small, hard to recycle. All sorts of challenges around PPWR is impacting on that. This is a packaging format widely used across the food, beverage, and household goods sectors because it's convenient, it's affordable, it's cheap. Consumers are encouraged to deposit clean and dry sachets. And there's already a challenge. There are many product formats that will be hard to clean and dry, and will consumers actually be bothered to do that? So I'll be interested to see if it's ever published, the results of this scheme how many are collected, and what and if and when they are recycled into and into what. Next up and last in this section is a patent from the patent zone. This is Hansol Paper from South Korea, and they've developed a food pack that focuses on making disposal easier by allowing separations of materials after use. Now, this is quite a familiar activity in food trays, but what we're doing is just reflecting some new initiatives coming through the innovation pipeline. So the key feature is a hybrid structure where the plastic inner container holds the food is supported by an outer paper-based frame, allowing the two materials to be handled separately at end of life. The couple of big challenges here is one is consumer communication, making it clear that consumers need to separate the two materials. And the second challenge is, will they do it? Because the two things are pivotal to ensure that the product is recycled. Okay, the last packaging trend area is paperization, and this continues to be one of the most visible global packaging innovation trends, driven by a number of factors. Consumers have demanded it, whether it's right for the environment or not. They think, I'm not saying it's not right for the environment, but consumers think it's the best material in terms of environmentally friendliness, in contrast to their attitudes to plastic. So it's very much a sort of a polarization, and so inevitably lots of new initiatives have come down the line to increase the number of paper-based and 100% paper solutions across food, drink, personal care, household products, e-commerce, and multi-pack formats. So first up is Blue Ocean Closures, who will be familiar to anyone that's watched our webinars over the years. They are based in Stockholm, and they've announced a reduction in the price of their fiber-based screw caps following developments in material selection and manufacturing processes. So they've recognized and acknowledged one of the biggest challenges to rolling out paper-based solutions isn't necessarily the functionality, is the cost. So the company introduced its fiber-based closures commercially 2 years ago as an alternative to conventional plastic caps and closures used across a range of packaging applications. According to the company, recent improvements in production efficiency and material utilization have enabled the cost reduction whilst maintaining the functionality of the closure. Next up is Marbelis, a company based in Belgium, and they developed EFEM, a smart label technology designed to simplify the material structure of connected packaging used for NFC and RFID applications. This is a growing area. Many RFID packs are not recyclable. So this innovation addresses the growing demand for digital traceability, authentication, and consumer engagement features, whilst reducing the complexity of conventional smart materials. Next up is EasySnap Technology, and they've been around a while now, and we've been tracking their initiatives, and they've developed PaperSnap, a paper-based liquid dose packaging format designed for liquid products across food, cosmetics, pharmaceutical, pet care, and household chemical applications. The pack is manufactured with more than 80% FSC certified paper, including paper-based laminates, and the company states that the material could be traced back to its source to support supply chain transparency. PaperSnap is engineered to be folded and squeezed within one hand, enabling controlled dispensing whilst maintaining hygiene and ease of use. They report that the format enables consumers to dispense approximately 98% of the contained product, which may help reduce residual waste. And that residual waste is very important because there needs to be next to no residual waste if it's got any chance of being recycled. And last up, before we speak to Matthias, is Blendbox from the United States, and they developed a paper-based drink pack that includes internal agitators designed to help dissolve powders into liquid during shaking. So the main benefit of the invention is that the mixing elements are built directly into the folded paper structure, removing the need for separate plastic mixing balls or inserts. We've seen lots and lots of innovations in this area where contents are mixed on consumption, but they tend to be plastic based. So it's really interesting to see something tackling a paper based opportunity here. After forming, the container is sealed at the top and bottom and fitted with a removable cap for filling and drinking. Well, it'd have to be tethered if it's based in Europe. The technology may be suitable for powdered nutritional drinks, instant beverages, supplements, or similar products prepared directly inside the pack. Now, that's an interesting long-term IP development. I'm now delighted to introduce today's guest speaker, which is Matthias Krätschell, Business Creation Manager for Barriers, Paper and Board within Kemira's New Ventures and Services team across EMEA. Matthias has over 20 years of experience in the packaging industry, having worked in sales and business development roles with both converters and material suppliers since 2004. He joined Kemira 2.5 years ago, where he focuses on developing innovative barrier solutions for paper and board packaging. What really stands out is Matthias' passion for bringing together different parts of the packaging value chain to create more sustainable packaging solutions. So, Matthias, are you able to share your screen, please?
So today, again, putting recyclability as a decisive factor on the spot, in particular, meeting recyclability demands with dispersion coatings from regulation to repulping. Couple of words about Kemira. So I had mentioned the global reach. There is a strong foundation in research and innovation on top of or along with the global reach with key R&D centers in Europe, the US, and Asia. Now, putting a little bit into scope today's topic when looking at dispersion barriers. So what is our view at Kemira today? As would be the first point before we go into guidelines for fiber-based packaging. Look at the Kemira PhenoGuard dispersion barrier coatings, then at the PPWR as the set for design of recycling, EPR that is driving recyclability and is becoming a cost factor. Assessing recyclability with CP method, then recyclability benchmark study results, and finally end-to-end expertise for barrier-coated grades. So to put it a bit into perspective, what are dispersion barrier coatings? What is their function? What is their role today? So they undoubtedly they have a measurable increase of sustainability of packaging in multiple ways. The strong demand for such solutions, and where you mentioned also the renewables. So new solutions are the demand is driving innovation. Many innovative solutions are being developed and tested. So every step counts to make packaging more sustainable. The following are steps that Kemira undertakes. So PFAS and PE replacement through high-performance barrier coatings. And we will focus on recyclability of these in a minute. Then reducing fossil feedstock through biomass balance, increasing renewable content in barrier coatings gradually, creating blends or combinations with renewable materials, invest in the development of renewable and scalable barrier solutions. So there's a lot when it comes to making packaging more sustainable, more circular, reducing plastic, reducing CO2 footprint, and then maintaining and increasing circularity. So these broad undertakings require broad capabilities and profound understanding of how to design packaging. If we look at packaging design requirements today, we are balancing multiple constraints at the same time. From packaging, we need functionality, barrier performance to protect packed goods, strength properties for durability and usability, safety, especially in food contacts, resource efficiency, and increasingly digitalization, which can be often coupled for optimized raw material utilization in the paper and board production process. But the fastest evolving requirement is recyclability. The packaging must be recyclable in real industrial conditions with efficient fiber recovery. In practice, this means efficient disintegration of packaging in repulping, reusing fibers with minimal rejects, and to maintain stable process behavior with reused fibers. So how do we combine barrier functionality with recyclability? So this is where water-based dispersion coatings come in. At Kemira, with Fenogard products, GO for grease and oil and GWR for grease and water resistance, we offer solutions for excellent oil and grease resistance, very good water holdouts, water vapor resistance, and heat sealability. And importantly, they are easily recyclable and repulpable and food-safe alternatives to PE coatings and PFAS-based solutions. So from an application point of view, they run on existing coating lines. They're suitable for both paper and board. They cover a wide range of food packaging uses, and both are commercially available and already being used in the market. So the key idea is simple. Fenogards deliver performance without compromising fiber recovery. Now let's look at regulation side, as this is really what is reshaping the industry. So the upcoming EU packaging waste regulation, I guess we have all heard about it by now, sets a very clear direction. By 2030, all packaging placed on the EU market must be recyclable. Important here is that recyclability is now precisely defined. So it's no longer enough that packaging could be recycled in theory, but now it must be collected, sorted, and reprocessed into raw material at scale and in real industrial recycling systems. So to make this measurable, PPWR introduces performance grades, A, B, and C levels for all packaging. The packaging below 70% is considered non-recyclable and cannot be placed on the market from 2030. And requirements will tighten further over time so that by 2038, even grade C will be phased out. Besides that recyclability is a requirement for market access, it is also becoming a cost driver. So extended reducer responsibility EPR systems will require producers to pay for collection, sorting, and recycling of their packaging. These fees are eco-modulated, meaning packaging that is easy to recycle, triggering lower fees like dispersion-coated paper and board packaging that are compatible in conventional paper streams, releasing fibers efficiently for use. And packaging that is difficult to recycle, triggering higher fees, PE-coated, for example, PE-coated composite materials requiring a special recycling process and create more rejects. Under the PPWR framework, the timeline is quite important. By around 2028, the EU will define detailed recyclability criteria and methodologies. And around 2030 onwards, EPR fees will be implemented, and then recyclability performance will directly determine market access and cost. To make this more concrete, let's look at a real example of a UK's EPR scheme in place. Under the EPR system, here packaging is classified based on how it behaves in recycling. So PE-coated board is classified as a composite material. Dispersion-coated board is classified as a paper. And that classification drives the fees. Now, why does it matter? There is a cost calculation here based on the best knowledge in terms of the cost. EPR fees have been collected from DEFRA and the EPR compliance guide. So even if PE and dispersion solutions have similar raw material and conversion costs, their total cost of ownership can be very different due to the end-of-life cost, roughly 250 to 300 pounds per ton in this example. So the key takeaway here is recyclability is now directly linked also to profitability. So how do we measure recyclability? Today, the industry uses widely the harmonized CEPI recyclability lab test method. This method simulates the key steps of a real paper recycling mill: pulping, screening, fiber recovery. It assesses how the packaging behave inside the recycling process, and according to the current interpretation, the recyclability performance grading is based on waste collection and sorting compatibility with the recycling process. Is it conventional or a specialized process, plus the score result achieved by the CEPI method. The CEPI method focuses on 4 critical aspects: fiber yield, how much usable fibers are recovered; contaminants and stickies, how much residues stay after repulping and what is their impact on water systems and machine runnability; processability, can the recycled material be processed in standard recycling conditions, or is a specialized process infrastructure required; and fourth, rejects, how much coarse and fine reject material is generated and lost as waste. Now that we understand the framework, how recyclability is regulated, defined, and measured, let's look at what happens in practice and how different barrier solutions behave under the repulping stage. So we conducted a benchmark study in lab scale comparing Phenogard coated board existing in the market, other commercial dispersion coatings, and PE coated board. The study was conducted under CEPI standard conditions, simulating a real recycling mill with conventional process. So it replicates key process steps like pulping, screening, and fiber recovery. So it gives a realistic view of how materials behave in industrial recycling. Before we look at the results, let's take a moment to understand how recyclability is actually evaluated in the CEPI method. The recyclability score combines multiple parameters. Screening yield, the most important driver. It tells how much usable fiber we actually recover. Higher yield means less material loss, cost savings, and high recyclability performance. Second, amount of dissolved and colloidal substances that are ending up to the water system after repulping, impacting water quality and stability of water systems. Visual impurities indicates the quality of the recovered pulp. And finally, sheet adhesion or stickies tells about the sticky content in recovered fibers that can use operational problems like deposit issues affecting to machine runnability and process efficiency. So it's not a metric, it's a system view of recyclability. The results are quite clear. Dispersion-coated materials achieve very high recyclability scores, above 90, which is considered best-in-class performance. Phenogard provides leading performance within the top tier. This is driven by high fiber yields, very low coarse rejects. In contrast, the PE-coated materials show lower performance, especially in terms of fiber recovery and high coarse reject levels. Here, the key insight is that the behavior of coating layers defines recycling performance, and PE coating prevents fiber release and recyclability drops immediately. This slide is about, sorry. So here, this slide explains where the difference exists, actually. So in the repulping process, PE coatings remain as intact plastic films. These pieces of films do not disintegrate, trap fibers, and accumulate as coarse rejects on screens. This leads to fiber losses, screen plugging, and process instability. In contrast, Phenogard GWR dispersion barrier coated board disintegrates into fine particles. And this basically means releasing fibers efficiently, pass through screening, and maintain stable process conditions. So let's look now what happens in the water phase. As we saw, dispersion coatings disintegrate during repulping. They form fine hydrophobic particles that enter the process water. The challenge is, if not properly managed, small particles could accumulate over time, affect water quality, and impact process stability by interfering with retention and dewatering and increasing risk of deposits. This is where chemical expertise makes the difference, as demonstrated in our study. Right fixation chemistry binds particles back onto fibers, capturing around 80 to 85% in the fiber loop. Chemically enhanced wastewater treatment removes most of the rest, combined up to 95 to 98 total removal efficiency. So the important point and bottom line here is, when these particles are actively controlled within the process, it ensures clean water circuits, stable operation, and high recyclability performance. And today, this connects directly to a broader topic, microplastics, because these small particles are often discussed as a concern, whether they accumulate in water systems or leave the mill. So we have looked at basically end-to-end processes, including what we do, what we can do in mills when we work with recycled fibers. And if we bring everything together to succeed under tightening regulation requirements, we need packaging solutions that deliver at the same time performance and barrier functionality, recyclability and high fiber recovery, regulatory and food safety compliance, cost efficiency with total cost of ownership approach. And that requires end-to-end chemistry expertise, as Kemira is able and open to provide. Our complete portfolio and application know-how supports producers across the entire life cycle, from pulping to paper making, and from coating to recycling behavior and wastewater treatment. That is how Kemira contributes to delivering truly circular solutions, with Phenogard Go and GWR commercially available today. With that circularity mindset and end-to-end chemistry expertise, Kemira is exploring also renewable feedstock for various solutions. Phenogard Go, by the way, has 25% renewable content, and there is much more in the development pipeline. So watch out for circular barrier news from Kemira. And a little spoiler to probably one of our next presentations, and hopefully without technical hurdles, but we are developing fully renewable and recyclable biodegradable barrier coatings. So watch out for news on Chem Alpha soon, and obviously also for further news in the barrier coating space for sustainable packaging solutions. Thank you.
Excellent. Thank you, Matthias. Can you, brilliant. Thank you very much. We've got a few questions. If you could share your camera, and then we come off the presentation, then that people can see us properly, I guess. Yeah.
Thank you.
Thank you very much. Brilliant. Right. So the first question we've got is, how representative is the CP lab test versus real industrial recycling?
Yeah, very good question. So this method has been developed for quite years and also been validated by independent labs. And there have been hundreds of tests run by all major pulp and paper companies. So there are also many recyclers that have verified the test, and some are then actually also using it in their own operations to provide guidance. And it is by far the most relevant and adopted method. Of course, there is also, as with all methods, some things that probably can't be simulated perfectly, but it's a very validated method.
Okay. Next question is, what types of testing do you do to ensure packaging quality and safety? For example, when blending raw materials to create a new material for packaging. So what types of testing do you do?
Yeah, this is very broad. It really starts from actually first looking at the use case and looking at the requirements and looking at the food contact requirements, and then starting with lab coatings, with different test point setups, looking at the entire performance results in the lab, and then depending on the relation then with the prospect, also sharing the results to develop further.
Okay, brilliant. And what about another question here? Do you measure the coating thickness of the water-based dispersion barrier coatings in the same way you would traditional coatings used in this area?
Well, we can measure, or we measure weight, basically.
Sure.
And then, of course, also taking samples, for example, from trials and doing measurements, including the coat weight, to really understand what is the paper, what is the non-paper threshold, and where do we get in the barrier performance with either adding or reducing the coat weight.
Okay. Question here about plastic-free claims. I mean, does Kemira offer plastic-free solutions based on SUPD definition?
Yeah, the famous SUPD, it is indeed a big question mark. So taking the terms very strictly, then that is debatable. There is one renewable solution where the product is actually occurring in nature. It is marine degradable. It has no plastic nor microplastic content, but the definition of the SUPD would suggest that it is covered by or in scope of the SUPD. So there's, I guess, also like with other renewable ones or bio-based ones, the discussion is the SUPD scope and definition the right one.
Okay. Question about heat seal. So if you remove the need to heat seal, is it easier or cheaper, or cheaper to formulate dispersion coatings that have less non-renewable content?
Yeah, I think it depends actually on the renewable material that is being tested in the blend. So I think there is not a straightforward answer, but we have seen what we did. So blending renewable material with the conventional one as a hybrid, we achieve very good performance, and that is of course the target. Then also to have the entire performance from 100% renewable material. Okay,
brilliant. The engagement has been fantastic. We've got so many questions. So I think what we can agree to do is collate all the questions at the end, and we'll send out your responses in a few days' time, if that's okay. We've got time.
Yeah, absolutely. Yeah. And once again, apologies for this technical.
Not at all. Not at all. We've got time for two more questions, problem. I think. So, got a question from my friend Ton. Is there a risk of pinholes when used on a rougher surface when fibers could penetrate the coating?
Yeah, obviously the surface does play a role, and it is kind of a system approach. So having the right paper with a smooth surface, or board with a smooth surface, definitely helps. Then also in terms of how much coat weight you need or coverage you need. So definitely the substrate surface matters indeed.
Okay. And the last question is from Katie King, who we showed one of her innovations earlier from Lavazza. Are your coatings in scope of SUPD if used for cups? If not, please can you explain more on why not, if you're able to do that in a minute.
Yeah. So we do have a renewable solution based on PHA biopolymers, which we tested for the cup application and also for lids. There's basically a ready solution close to market, go-to-market readiness. But indeed, PHA is known as being in scope, and that's another bio-based material that probably sharing others' opinion as well should probably be exempted from the SUPD. But that is the main one we see for cup application, which on the other hand, if you think about new cup concepts, where the adhesive is exempted from the SUPD, these products based on PHA that we developed could be used as a bio-based adhesive. So in that application, they would not be exempted. But as a full surface barrier, they would be in scope. At the same time, we do a lot of discovery and innovation work and looking at new technologies that we can bring, that we test and then bring to scale according to the regulatory requirements.
Excellent answer. Thank you very, very much. Right, we're pretty much done. So as I said, we'll get any questions that haven't been answered. We'll collate them and get them over to everyone that's registered in the next few days. We'll get the recording edited and over to you as soon as we can. It may be tomorrow, more likely to be Monday. Our next webinar is at the same time of day, 3 p.m. British Summer Time, on a Thursday, the 30th of July, and we'll give you details on how to book that then. I'd just like to thank you all for attending our webinar today, and I look forward to seeing you at our next one. So thank you very much, everybody. Have a good rest of the day.
Thank you very much.
Thank you, Matthias. Appreciate it.